Okay, now these look like you already know how to do them, but there's a new method I'm going to teach you that I really don't teach in Algebra 2 of solving these. Because right now you look at it, you're like, okay, there's two answers. I'm going to have to set it equal to 0. It's already set equal to 0, GCFT, and if the t doesn't work, I'll just use my quadratic formula. And that does get you the answer. But I know Coach Larson has a quiz in Trig, college might have too, where they say the way you have to solve the equation. It's by a method you don't know. It's called by completing the square. Completing the square is that b divided by 2 to the second power thing that you do. But all you did on the video was simply take the equation and rewrite it. Okay, now you're actually going to use it to solve the equation. Okay, so again, this is new. Now, when you're taking tests for me, stick with the old method. Okay, just GCFT, t doesn't work, go to the quadratic, fails, go to the quadratic formula. But I think you should be exposed to this method here, so when you get to it, you're not just totally lost. Now, there are two answers. And I'm going to make when I use complete the square, I'm going to make a table down here because we're going to end up with an equation where we use the q, okay? Just see how it shakes out. Now, when you complete the square, you keep the x squared and the x where they're at, but you need to kick out the 3, the constant, and put that with the 0. So now you have the equation x squared plus 6x plus blank, because you're going to use, that's a, that's b, and c, you're going to bring the new number in. And then 0 plus 3 is 3. Okay, now to find my new number that we bring in, my c, okay, I'm trying to create a perfect squared trinomial where if I do the t-chart, I'm going to find the exact same two factors. So again, c equals b divided by 2 to the second power. So b is 6 divided by 2 to the second. That's going to be 3 to the second, and that ends up as 9. So we bring a 9 in. Now, there was a problem where if I brought 9 into this side, I would minus 9, but I'm going to the opposite side of the equation now. I'm not going to be on the same side of the equals, so I do the exact same thing, plus 9. You switch to minus 9 if you're working on the same side, okay? Okay, now I go to my t-table, and again, A, B, C, so 1, 6, and 9. A times C is 9. And remember, you want to add to try to get to 6, which is positive, and it's got to be the same two factors, 3 by 3. And since 6 is positive, okay, put positive on 3, and that positive up there means the signs have to be the same, okay? Okay, so since A is 1, I would have x plus 3 and x plus 3, so I write that as x plus 3 quantity squared, okay, equals 12. Now this becomes a q problem, okay? So I replace that, and I got x plus 3, x plus 3. Okay, so I know q to the second equals 12. And I'm going to kick this up a notch here, okay? So I find, because in college and maybe Mr. Larson's class, he's going to want the answers written differently. He's going to want your square roots to be simplified with this, not just using the calculator and rounding the decimal. Okay, so the square root of 12, well, it's not a perfect square, but I know it can be divided by 4. 4 and 3. So that's 2. I don't need the I because 12 was not a negative. So over here I write 2 square root 3. 2 square root 3. Now you're going to minus 3, but if there's a square root over there, you put minus 3 behind that, and that's your first answer. So 2 square root of 3 minus 3. Those are not like terms because this 2 has a square root of 3. That 3 does not. So you keep them separate. Minus 3, and that's a negative right there. So the other answer is negative 2 square root 3 minus 3. Okay? And I really don't want to go through plugging that into the equations about a 30-minute process, okay? Just trust what you did. This is just preparation work for higher level math classes where it'll be you and other high level people. Okay, x squared minus 12x plus 7 equals 0. So again, you got two answers. But again, when you're completing the square, okay, you're going to want to get the constant over here. So I subtract 7 from both sides. So now my end game is to go x to the second minus 12x. And then I'm going to bring a new number in here, okay? Then 0 minus 7 is negative 7. Okay, remember, a is 1, b is negative 12, and I'm going to look for a new c. Okay, remember, c is equal to, when you're using this completing the square, b divided by 2 to the second. C equals, okay, so b is negative 12 divided by 2 to the second, but that ends up being negative 6. But when I take negative 6 times negative 6, that's 36, okay? So my new c value is 36. But if I plus 36 to that side, I go to the other side now and do the same thing, okay? Again, it wasn't like that one video I showed you guys where you were trying to rewrite an equation from standard to vertex form, okay? You're now going to the other side, so that's why you don't make it plus 36 minus 36. You do that from the same side. Okay, now I go to my t-chart, a times c, 36, positive. Remember, whenever it's positive, the signs will be the same, signs on the factors, okay? Okay, and you're trying to add to try to get to 12, which is negative. Okay, well, we know it's 6 and 6. Now, 12 is negative, so I need a negative on the two factors, okay? So, a is 1, so it would be x minus 6, but then I can write that as x minus 6 quantity squared, and over there you got 29. Okay, so now it becomes a q problem, okay? So I replace q with q to the second equals 29. So I'm going to have x minus 6 equals, and x minus 6 equals, and then I'm going to square root at 29. Okay, but again, a funny thing happens in the sense that 29 is not a perfect square, and it really doesn't divide by anything other than 1, so we're just going to keep that as the square root of 29, okay? So when I add 6, I got to remember, don't add 6 to actual 29, because that's the square root of 29. We're just going to put a plus 6 behind it. So I put square root of 29 plus 6. Then I plus 6. Oh, by the way, put a negative in front of the second one. I'm forgetting to do that for whatever reason. Okay, that's negative square root 29 plus 6. Okay, it's still plus 6, just that's a positive, that's a negative. Just put the negative out front. Okay, my next one. You have two answers. You have x squared and x, but instead of looking to set up the boxes, I'm going to move the 2 over. So now I have x squared plus 4x plus blank equals negative 2. And a is 1, b is 4. I'm looking for a new c. Okay. So c equals b divided by 2 to the second, which means c equals 4 divided by 2 to the second, which means that c is equal to 4, because 4 divided by 2 is 2 to the second power is 4. So we're going to plus 4, and we'll also add 4 to this other opposite side, because now it's like a balance. You're not doing it on the same side. Okay. A times c is 4, positive 4. Okay. So that means the signs have to be identical of the two factors that we find. And we're trying to add to arrive at positive 4. Okay. So it's got to be 2 times 2. Okay. Since 4 is positive, you got to have a positive on one of them, and same on a positive mean they have to be the same. Okay. 2 times 2 is 4. 2 plus 2 is 4. Okay, so we're going to write that as x plus 2 quantity squared, because it would be x plus 2, because a is 1. So I write that as x plus 2 quantity squared equals 2. And now I go into my q method. So q to the second equals 2. Don't forget, you're going to bring back the x plus 2 down here, because that's what q really is. I'm just writing the equation so it's simpler. 2 is not a perfect square, okay? The only thing it divides by is 1, so I'm just going to put square root of 2 and then square root of 2 negative in front, okay? So I subtract 2, but then I put that behind the square root of 2. So I put square root of 2 minus 2. That can't be simplified. And now I have negative square root of 2 minus 2. Okay. Okay, x to the second power plus 2 equals 6x plus 4. Okay. This one's a little bit confusing, so I'm glad I'm doing it. There's 2 answers. Now remember, you want x squared and x over here. Okay, so we need to subtract it. It's like the 6x and the 2 should switch places. So I'm going to subtract 6x, and there's nothing, no like term over there. Okay, so I'll just put a minus 6x up there. Now the 2 is a constant because it doesn't have x. That should come over here. So now I have x to the second minus 6x, and that's all I have, so I'm ready to draw the blank. Then 4 minus 2 is 2. Okay, so now I'm set to go to find my c. Okay, so c equals b over 2 squared. Okay, so b is 6. 6 divided by 2, or negative 6. It doesn't really matter because you end up taking it to the second. So c is negative 3 squared, which is 9. So we bring in 9, and we also add 9 to there. So now I have 1x to the second minus 6x plus 9 equals 11, although you don't really need to write that because now I'm going to the table. 8 times c, you got 9 positive. Okay, so that tells me that whatever factors I find, the signs have to be the same. They have to be identical. Okay, so it's an adding problem. We're trying to add to 6 negative. Well, we know it's 3 and 3. Okay. Now 6 negative means you're going to have negative 3 there, and the same sign, negative 3. So a is a 1, so I know that's x minus 3 times x minus 3. So we write that as x minus 3 quantity squared equals 11. Okay. Okay, so we're going to be replacing this with q. So x minus 3 equals x minus 3 equals q to the second equals 11, and then I've squared 11. Well, 11 obviously is not a perfect square. It divides by nothing other than 1. So I keep it as the square root of 11. So then I plus 3, and then I plus 3 behind there. So I write the square root of 11 plus 3. Remember, you don't add 11 plus 3. That's because that's wrong. 11 has a square root. The 3 does not. They're not like terms. Similar to when you have a number multiplied by x and a number that's not. You would not add those. By the way, put the negative on that side. Okay, so negative, just put the same thing with a negative in front of the square root of 11. Okay. So I have the square root of 11 plus 3 and negative square root of 11 plus 3. Okay, now again, I don't really test over this that much, but it is a method you should be familiar with when he says complete the square. You keep the x squared and the x on one side, the constant moves over, you use your b over 2 squared, you get a perfect square trinomial, it becomes a q problem. Okay, that's all I was saying on that. I hope it has been informative, and if you have questions when working the problems, let me know.